So I'm going to be talking today about Go build flags. It was just something that kind of when I was learning Go, I skipped a bit. I learned what Go build was, built my first binary, and then moved on. But since then, I've learned some new things, and I kind of want to just briefly go over them because I think some people might find them interesting as well. So we're going to go through how to bundle assets into the binary, compile different code per environment, build time variable injection, wrong pause, and a special reduced binary size by 77%-ish. There's a caveat. So first of all, before we begin, what are Go directives? So they are special comments that give instructions to the Go toolchain. So they look like the line here. So it looks like a normal comment. It's prefixed with Go colon, and there is no space between. There are roughly 13 Go directives, I think. Most people are going to be kind of most used to seeing Go generate, but there is also, or what we'll be discussing today, is Go embed and Go build. So the first one is Go embed. So this is kind of the main three patterns that you can have. So the first one is importing a file into a slice of bytes, or a byte slice, and the second into a string, and then the third one is quite interesting, and it's an embed.filesystem type, which, as it sounds, it's a file system that you can use from the embed package, so you can access whatever you store within your binary as if it was a local file system. I'm sure there are some caveats to that, but that is it. For the first one, probably don't use a byte slice for a text file. It should probably be more like an image or an MP3 file. Some of the cool uses of this, other than just CSS, is if you wanted to embed public SSH keys for a binary you were using, instead of having to lug that around with the binary itself, you can just use one file. The next one is how to compile different code per environment using the Go build flag. So here are some more Go directives, an example of them all, an example of Go build. And the first one is the Go build with the debug tag. And what this means is if you put this in the top of your file, you will have to actually declare when you're using Go build that you want to include this file within your binary. Second one down, the exclamation mark basically is a not. So if you don't include the tag debug, this file will be included. And the final two are special ones, whereby these actually relate to the operating system that it is being built on and or for, if you're doing cross compiling. So the first one is Linux, second one Windows. I believe macOS has one, and there might be some more special ones. So hey, that's a take-home task. You can have a look for yourselves. If you were curious about the last two, in the sense of like, why would you ever need them? If, for example, you were building and releasing binaries for, let's say, Linux and Windows systems, and you wanted to implement CPU usage monitoring, instead of having one file with a different function that does a lookup and tries to figure out what system the binary is running on, you can physically declare the same function signature in two separate files, and they will be imported when you build for that specific operating system. So, the binary is not overloaded with specific code for Windows when it's only going to be running on Linux. And so an example of how to use these. So the first one would be you have to be specific and use the debug tag when building. And the last two are using the Go OS environment variable when you are trying to compile for a different operating system. An example that I thought might be useful was I spun up a really, really small HTTP. Wow, sorry everyone. A small HTTP server. There we go, got there. Where when you have the debug flag, you have a lovely, nice debug endpoint that gives you a bit of information about the service that's running. And then when you have the release flag, or when you don't have the debug tag, you just get a 404 error not found. So if we were to compile the top and the bottom with these two commands, you would have the output of the below here. So important to note, you're not actually changing any code between this. You're just compiling it differently, and it has a different output based on what you are building it for. The other use that I think is probably more useful for most people is actually specifying how to build, or what tests to run. It's been a long day. English is my first language, but just not today. For example, an integration test, you might not run integration tests locally, but you might add the integration tag within your CI, because you might have your database set up for tests there. And a little extra is go build and go embed together. So this is something that you can do this. You can join both together, and its uses, for example, here with the example I am using, is the CSS changes between your compile type. So if you are compiling in your debug mode with your debug tag, you will have lovely, it's meant to be red, but you'll have lovely orange CSS, it turns out. And if you are compiling for production, you get a lovely production purple. And as you can tell, AI helped me with this, so it's full of emojis and fun. Yes, cool. Quick, moving on to the next one is build time variable injection. So if in our example we had a package called version and we had a version.go file, we can define variables whereby they can have some default really, English is my first language. We can have some default variables that what we might use when we are running the code locally. Not much use. I don't need to check the version that I'm running locally. However, if we then build within our CI using the -ld flags flag, you can actually pass and define these variables at build time. For example, using the version, build time, and git commit from the CI pipeline that you're within, it's the equivalent of doing a git commit whereby you actually define these manually. Its use is very specific. You will either need it or you won't, but it is very nice, and I quite like the idea of not having to fill my git commit history with loads of versions, or have separate branches for releases. You can simply do it in your CI. So as you can see here, if you curl the version endpoint, there are no code changes, but these were edited at compile time. Another interesting use that I thought of while reviewing these slides earlier was if you were to white label your application, you would be able to basically define some level of configuration that you pass in at build time, so you don't have to package configuration in the sense of extra files and whatnot per company you were outsourcing it to. You could simply just say, hey, this one's for company X, this one's for company Y, very original, and they both use the same _app. And I think the bit everyone's been waiting for is how to reduce the binary size by 77%. So, build flags that might be useful. The top two basically remove data from the binary that's useful for debugging. So the first one removes the mapping of memory addresses to function names. Sometimes useful. I actually tested this locally and it didn't do what I expected. So use at your own risk and have fun. You probably didn't need that data anyway. And the second one is the -w flag passed via LD flags, which strips dwarf debug info. So I wrote down what dwarf stands for, and it is debugging with attributed record formats. Basically, it means if you remove this, the Go debugger won't work very well. But hey, who debugs in production directly? Not me, so I don't need that either. Trim path, we will look at the next slide. It is basically, it removes the path of where you developed this or compiled this locally, and it just replaces it with the module address. So it's a very small impact on my machine, but it's actually very useful if you want to have, I'm not even going to attempt to say that word, hide where your CI is running. And if you have multiple machines or multiple colleagues that build the same binary, you'll be able to have the same output if you add this, because it won't use the user's that's compiling it directory. It'll just use the module address, so you can double check that you both have the same binary. And the last one is static linking, whereby it ensures that all of the dependencies for the actual binary are stored within it. So a caveat, this does increase the size, but I thought it would be cheating if I just removed everything and showed you a binary that never ran. So yeah, I recommend that one. So here it is. I reduced it by 32%. So when I added all the flags, it reduced it by 32%. Hey, that's great. Thank you for coming. No, I'm joking. I cheated. I used the Ultimate Packer for executables. It is a very interesting tool that I discovered. I recommend looking it up. It's quite nerdy stuff, but it is, I'm going to say, an interesting read. It's a confusing read. But it reduces things by, I think it was around 50 to 80%. So on this small project, it decreased the binary size by 77%. If anyone works for a really, really successful company that outsources lots of Docker images, I'm sure we can save lots of bandwidth with this. And I know, so from 7 megabytes to 1 megabyte, 7 megabytes wasn't that big to start with. I tried it on Nala's repo, and we reduced the size by 82%. So it's actually pretty impressive. I recommend having a look at that. That is all from me. Thank you very much for listening. Any questions?